All right, class, this is going to be kind of a weird video because I recorded it already and it doesn't have sound. And so, because it doesn't have sound, uh, I need to talk through it as it goes. So, this is our problem here, and here's what's going to happen. I've pre-written this and we're actually watching a video. You can see that down here. I can fast forward it, move it backwards and forward, but I've already recorded this entire video and it's 16 minutes long. And so I don't want to record and rewrite the whole thing. And so I'm going to let it play and I'm just going to talk through it as it goes. So it might be a little messed up with the audio to the video, but it's because I'm gonna have to kind of see what I wrote to know what I was saying at the time because I can't hear it either. So just bear with me on this, and we will get through. Okay, so here we go. And it should be playing. It is. So this is a problem that we have. And one thing that I have explained in the previous video is with this, we have actually three factors on the bottom. So one of the factors is a 2x. The other factor is an x plus 1, and it's repeated because it's got that 2 power there. So there I'm circling the 2x to show you that's one factor. That's the same as 2x minus 0. So x is the same as x minus 0, so that is a factor. So you would still have like an a over 2x factor on the other side. And so with that, on the other side, we'll put a over 2x. And then we have the next term, which is repeated. So we're going to put a b over x plus 1. There I've circled the 2 to show that it is repeated twice. And since that's the case, it is linear also. So I put it's a repeated linear factor. And because it's repeated, we have to add a second term. So there is the second term. Okay, from there we go to the next page. And what I was going to do in this is show you and explain to you just all of the pieces. So now I'm going to fast forward a little bit. So here's my example right here. And we put it through. And notice there's an x minus 3. It's only to the first power. And so with that, see there's the 1 right there. And because it's to the first power, we only need one term for it. The second term right there is repeated. So you can see the 2 there, it repeats. And so I need 2 terms to be able to get that done. The third set of factors in the bottom is repeated 3 times. You can see it right there. So I need 3 factors. So you see there's where we get the D, the E, and the F. Now the x squared plus 1 is a quadratic, and it doesn't factor. So there's a difference between any old quadratic and irreducible quadratics. Irreducible ones don't factor. And so a few ways that you can go about seeing this is x squared plus 1 is a parabola that's shifted up 1 unit. So it has no intercepts. You see I've squiggled it out there to show that there are no intercepts. So there's no zeros. And if there's no zeros, there are no factors. So that doesn't factor. Another way of doing it would be to set x squared plus 1 equal to 0 and solve it. And when you do that, you would get plus or minus I. That shows that it's got imaginary roots. Or you can check b squared minus 4ac. That's called the discriminant. And remember, if it's positive, you have 2 zeros. They're distinct. If it's 0, you have 1 repeated 0. Both of those are real. And if it's negative, you have 2 complex roots. So in ours, the b term is 0 because it's x squared plus 0x plus 1. So we have 0 minus 4 times 1 times 1, which is negative 4. So it has complex roots. Okay, so then now, so now we put a line on top. And the way that I think about this is on the bottom, that's a line. It's degree 1. The top, that is a constant, and constants are degree 0. So whatever the degree on bottom is, you put 1 degree less on top. So in this case, we have a quadratic degree 2 on bottom, so we put degree 1 on top. And the final one, the x squared plus 2x plus 5, is repeated twice. So we need 1 for it the first time and 1 for it the second time. And then I just went through here kind of, and I showed you that those two correspond because that was twice, that twice there went for those two terms, that 3 repeated right there goes for those 3 terms. The single one gives you a single one, and those 2 correspond to those 2 right there. So that's how you set them up, and that's how you go through and figure out what terms you have. So now we're going back to the other page. So now we just proceed as normal. And so what we're going to do is clear the denominator. So I multiply both sides. On the left side, we get everything canceling, and we just get the numerator. On the left side, when I distribute, the 2 x's cancel, and I'm going to get ax plus 1 squared. The second term, the x plus 1 cancels, and I'll get 2bx and an x plus 1 because there was 2 of them there. And then on the last term, both the x plus 1's cancel, and I would just get 2cx. So now, in this case, since we have two zeros, but we have 3 factors, this is not conducive. So we have 3 individual factors, 3 terms, and but we only have 2 zeros for it. So the 2x would give us a 0, and those 2 that I just circled give you -1. So I have 3 unknowns, but only 2 good zeros. For that reason, I'm not going to do pick values. I'm going to do equating coefficients. So what I've done here is I foiled out the x plus 1 squared, and there it is. I distributed the 2bx, so there it is on that. And then the 2cx goes at the end. Then I just distributed the a, that's the only thing I did in there, and then I cut it and put it over here. So then we start equating coefficients. So there I show there's the 2 terms that have the x squareds in them. So we're going to pull those out. Then we look at the x terms. There they are, underlined. And then we just have the a term last. Once you go through here, then, notice what's in front of the x squared on this side is an a plus 2b, and what's in front of the x on the other side is the 5. And so that gives us an equation a plus 2b is 5. The middle term is 2a plus 2b plus 2c, the coefficient in front of x. The coefficient in front of x on the other side is 20. And so we have another equation that's 2a plus 2b plus 2c equals 20. And finally, the constant term on the left is 8. Constant term on the right is a. So a then must equal 8. Now that we know a is 8, so this is a system of 3 equations with 3 unknowns. But it's not really. I mean, we have the middle one has 3 unknowns. We have one with 2 unknowns, and we have a single one that already has the value set. Once I know that a is 8, I can take that over here and substitute it in, and I can solve for b. So that's what happens next. Then once I have a and b, I can put them over here, and then I can solve for c. So if I plug in the a for 8, or the 8 for a, I can subtract, and I get -3/2. Now that I know a and b, I can put it in. 2 times 8 is 16. The 2's cancel. We get -3. 2c is 20. 16 minus 3 is 13. 20 minus 13 is 7. Divide by 2, and you get 7/2. So then, coming back to the other page, now I can put my answer together. So remember, it was supposed to be a over 2x, and a was 8. So it's going to be 8 over 2x. And then it's plus b. Now b, though, is -3/2 right there. And so I'm going to put a -3/2. Notice it was a plus, but I'm going to go minus there for it. And then c was 7/2 right there. So I'm going to put a 7/2 over x plus 1 squared. And that should be my final answer for that. So just as a recap, remember, the x factor just works as its own factor, and it needs its own piece in there. Repeated factors have multiple terms in them when you break them down. And then from there, you can choose either picking values. That's my abbreviation there with the PV, picking values, or you can equate coefficients. And if you equate coefficients, I will pick that sometimes if it's better and you have actual zeros. I then went back and showed that this problem has 2 real zeros. It had 2 factors, and it had 2 good zeros to them. And so I would have done this one the pick values way and get the answer there. However, you could still do it with equating coefficients. On the other side, you can see when you get the system, you still solve and you get the exact same answers. So there those answers match on the other side. So as a final recap, when you have distinct factors and each one has a good zero, I would pick zeros to solve the problem. When it has more letters that you don't know than you have good values to choose, I would always equate coefficients and solve that system. So the final thing is I do have one more example coming with quadratic factors, and I will upload that later on this afternoon. All right? Take care, you guys. Hang in there. I'm proud of you. Bye-bye.